And finally, problem 4. Construct the sixth order Taylor polynomial and the Taylor series for cosine x. So our function is cosine x. And we are going to need to take 6 derivatives, so let's get started. The first derivative is negative sine of x. The second derivative is negative cosine of x. The third derivative is sine of x. The fourth derivative is cosine of x. The fifth derivative is negative sine of x. And the sixth derivative is negative cosine of x. Okay, and we're creating a Taylor polynomial right around where x is equal to 0. So we need to plug 0 into each one of these. So f of 0 is 1. That's going to give us 0. The second derivative at 0 is negative 1, 0. The fourth derivative at 0 is going to give us 1. The fifth will give us 0. The sixth at 0 is going to give us negative 1. So our polynomial is going to be, well, this is our original function, so we're going to start with 1. This is our second derivative, and it's negative 1, so we're going to have minus 1 over 2 factorial x squared. For the fourth, we're going to have plus 1 over 4 factorial x to the fourth. Fifth is going to be nothing. The sixth is going to be minus 1 over 6 factorial x to the sixth. Our Taylor series, so this is, again, just our sixth order Taylor polynomial, but our infinite Taylor series, if we start at 0 and go to infinity, it looks like we're going to have negative 1 to the, let's see, we want that to be positive. So k, and then we're going to have times x to the 2k over 2k factorial, and let's just, so that works. So when x is equal to 1, we have something negative. When k is equal to 2, is positive. Okay, so there we have that. Okay, incidentally, here's something else we could have done. So there's our sixth order Taylor polynomial for cosine of x. Test it on your calculator. It gives you kind of a good match. But here's the other amazing thing that we could say. We know that the polynomial for sine, right, sine of x, is just x minus 1 over 3 factorial x to the third plus 1 over 5 factorial x to the fifth minus 1 over 7 factorial x to the seventh. Cosine is the derivative of sine. So if I just took the derivative of this, it would give me 1 minus 1 over 3 factorial times 3x squared, 1 over 5 factorial times 5x to the fourth, 1 over 7 factorial times 7x to the sixth. And if we simplify that, it gives us 1 minus 1 over, that's just going to give us 2 factorial x squared. This is going to give us 1 over 4 factorial x to the fourth. This is going to give us 1 over 6 factorial x to the sixth. So there's another way. Whoops, sorry. That's what I was saying. There's another way of getting the expansion for cosine. And now, if I want the expansion for cosine of 2x, well, here's what I'm going to do. You can test this out. You can do the fourth order Taylor polynomial from scratch. Tell me if you get this. Just check your work. So this is going to give us, this is just going to be 1/2 times 4. So that's 2x plus, and this is going to give us 16. So I'll do this out. 16, 4 factorial x to the fourth. And this is going to give us 2 to the sixth is 64. Boy, I don't feel like doing this. X to the sixth. But anyway, that should work as well. Yes, you do have to simplify those.